The cognition of space, cues that guide spatial behavior. Animals need to be able to guide their way through space to find food and shelter and other necessities. Instrumental behavior occurs in the context of space as well as time. Dead reckoning is using an internal sense of direction and distance to get from one location to a goal in a straight line. Animals use cues to navigate to a goal, and so do humans. There are two types of cues. The first one is a beacon. Beacons are cues that are very close to the goal that the animal can see at a distance and simply approach. Landmarks are cues that have a fixed relationship with the goal but aren't close to it. They are mainly used for configuration of landmarks. Spetch et al. In 1997 tested this with pigeons and humans, and he found that pigeons searched a fixed distance from one of the landmarks and humans always searched in the middle. Chang in 1986 tested rats on their ability to use geometric information and found that rats would go to the correct corner sometimes and would also choose the opposite corner a lot of the time as well. This suggested that rats were using geometric information. A geometric module is a representation of the global shape of the environment that's thought to be separate from the representations of individual landmarks. Spatial learning in radial and water mazes. The radial and water maze are two very common methods for studying spatial learning. A radial maze has a bunch of arms, up to 12 of them, and rats use cues to get around it to their goal. Place cells are cells that fire only when the rat is in a particular place in the maze. There are two ways to think about how rats represent space. The first one is that they might learn a mental map and mark each location on the map after it has been visited. The second is that locations might be stored as items on a list. The water maze was first developed by Richard Morris, and rats must learn to use either beacons or landmarks or the landmarks in the room to find the submerged platform. Morris had a lot of experiments, and he found that rats who started in a different location had no trouble finding the platform if it was in the same place. But if it was moved and they started in a different location, they took longer to find it, and they searched in the original place first. And he also found that rats with lesions in their hippocampus have trouble finding the platform. How do they do it? Sutherland, Chew, Baker, and Lingard in 1987 found that rats who were able to see all of their surroundings, not just half of them, were able to find the platform faster when they were put in a new position. Ellen, Soteras, and Wages in 1984 found that exploring links between places is important for being able to move efficiently through a larger space. Roberts and Pierce showed blocking effects in their experiments. In a group block, the beacon blocked learning about the spatial cues. In the control, they had no curtain, so they learned about the spatial cues in the room and found the platform faster. These findings suggest the rules governing learning of beacons and landmarks might not be so different from those that govern associative learning. But there are limits to this. Beacons don't block learning about geometric cues. This was proved in an experiment by Pierce et al. In 2001. This supports the geometric module. Also, organisms find goals in their environments and learn a global representation of the space. Although many types of learning at first appear different, from other types of learning, we have seen in earlier chapters there's surprising generality to the basic principles of learning.